Hello everybody, welcome to this talk about how to brew beer with Xamarin. My name is Ivo Krugers, I'm a senior Xamarin developer at Xablu, and I want to talk to you about the Mini Brew project. The Mini Brew project is about this machine. The company builds this machine, and this machine can brew 5 liters of beer for you at home. So first of all, I want to talk to you about how the brewing process goes actually, because I wasn't aware about how you brew beer, and so I think that's nice to set out here. So you got a few steps. You got the brewing, which is kind of the boiling and extraction of sugars and flavors from the ingredients. Then you go over to the fermenting stage, where everything ferments. I think the sugars are eaten up and alcohol is created, something like that. And last but not least, you want some bubbles and you want some foam in your beer, so there you put some CO2 in there to carbonate your beer, and then you're ready to drink. So that's about what a brewing process undertakes. So I've got here the Mini Brew, the machine. So I'm gonna take it apart for you and go through the parts. On top we have the lid. The lid has some compartments in here to be able to put some hops in there, and it's not to be able to put the hops in there. The importance is that the hops go into the brewing process at a different point in time than the grains that are in here. So they need to be in a separate compartment and are dropping into the boil at their needed time. Second is the mash tun. So the mash tun has some filters in here so that it keeps the grains within here, and the liquid, the hot water and liquid can go through it. The extraction of sugars and flavors can proceed. If you prepare your mash, it smells like bread. It's almost the best of the whole brewing process, I would say. But this is where you put your ingredients. Then you got the smart keg. This is where your beer ends up in. You set it here on the keg stand. Normally what you do is you plug it in. So what do we have here? We have 2 different machines. We got the base station and we got the keg here. And those are 2 different machines, so you need to consider them as 2 different machines. So the base station is for the brewing process. It can boil up the liquid or the waters up to 100 degrees Celsius, and the kegs cannot, but they certainly can regulate the temperature for you. So say 35 degrees or 25. Something like that, and depending on your recipe it adjusts in time automatically. So that's about these 2 machines. They run firmware. We call that firmware, C++ written software, which receives a recipe and then executes it. So furthermore, on the software side or the platform, we have Backend, of course, and we got a web application. The web application is for creating your own recipes, and the mobile app is just for following a recipe. So there's a small difference there, just to show you. So if you can go by brew packs, something like this. Your ingredients are in here, everything's prepared. You just open up the bags and put it into the place that it needs to go. That's for people like me. I kind of not know how the exact brewing process and the fermenting process should go, and this is all prepared, and the recipe as well. I just put everything in, I follow all the steps in the app, and get my beer done. And the other side is that you do your own recipes. Why you want to do that? Well, maybe you are a craft beer lover or expert, you want to play around, that's also possible. Or maybe you're a laboratory or something and you want to like find the best recipe possible, and you need a lot of different variants of your recipe. And of course, think of this, you got this keg of 5 liters here. The brewing process takes about 5 to 6 hours. The fermenting takes about like 2 to 3 weeks. So that takes a long time. And if you're waiting for your result and after 2 or 3 weeks, well, and then start over, that's not very efficient. So the base station is actually done after the brewing. So after like 5 or 6 hours, the machine, well, and some cleaning, the machine is ready to brew a new beer. But the keg, of course, not. But so if you buy yourself a shelf full of these kegs, you can easily experiment with only 5 liters each time to perfect your recipe. So that's a thing that you can do with this machine. They value quality, Mini Brew. So they work with raw ingredients. The mash tun is filled with raw grains, and hops are in the hop bags on top, on the lid. So that's instead of having something encapsulated in a capsule, something like a coffee machine, right? And then put everything in and then it goes. I mean, it's kind of automated in that same way, but you have fresh ingredients, so you get better beer. It's higher quality. It's craft beer. You get all kinds of weird beer, so dark. This one, for example, that I really like. It's a barley wine. It's 10%. Really good. And also another thing to think about. You do everything at home. So the only thing that you need is a brew pack and a water connection and electricity, and that is enough to brew your beer, instead of going to the shop, buying a lot of bottles, glass, trucks, gasoline usage, and all those things. So it has a good footprint as well. So that's also nice, right? So you got these features. As I said, you can brew packs, or you can make your own recipes. And there's just one more feature that I really like, and that's the self-cleaning function of the base station. You put some kind of vessel on here, put a washing tablet in there, some tubings, and just hit go on the app, and the machine cleans itself and the tubes inside of it, so that it's ready for the next use. So that's about the hardware that I have on my table here, and we're ready to go into the slides. Yeah, so how to brew beer with Xamarin. Let's go. So we talked about the Mini Brew project. You can see here the components. That left thingy there is that what I talked about with the self-cleaning. So yeah, have a look at them if you want. So it's nice. So the overview of the software, right? So we got the backend, that's kind of clear. We got applications, we got web applications, we got mobile application, and we got the base station and the keg, right? So remember that there are two. They're running firmware, so they also are written by the company. And we've got something in between. We call that the MQTT Broker, which is actually in charge of communicating all of the devices out there with our backend, but also with the user's application, right? So that they're mobiles. So there is a lot of flow of information. So when the machine is brewing, or not fermenting so much, but brewing, yes, it's sending out a message with process information or status information, which can be listened or tapped into. And that's what we do with the mobile application. We tap into a channel of the MQTT broker, and then we start receiving all these messages that come in that channel, and that we can use to show progress on the screen of the application. So first of all, the firmware. We've got two devices, as I stated several times now. So it's kind of a state machine. It goes to all the states. Depending on your recipe, states can maybe skipped or some others inserted. You also have to think about, how do I register my machine? Of course, when you start up your machine at home, it cannot connect to the internet. It needs to connect to your Wi-Fi network. And so you need to be able to set up your Wi-Fi credentials. And before that, you cannot do anything. So what kind of options do you have there? Well, you have Bluetooth, of course. And there's also another variant that you can use. You can let the firmware set up a hotspot and then connect to that, and then let it serve you a kind of captive portal. That's also a way to be able to connect. And once your device has your credentials, it can connect to the internet, and it will connect to the broker. Okay, the other thing that you need to be wary about, I mean, this is an IoT thing, so you can have disconnections. Drop connections can just be offline. All these scenarios you need to be taken into account. It's just some more edge cases that you need to program and unit test. The second thing that I find a challenging one is how do you update such a machine? I mean, you got all these machines at the clients at home. This machine, well, you need to write some specific software to download the latest version of the firmware, right? So that's also an extra challenge that you have there. And you can maybe just deposit your executable somewhere on the internet and use HTTPS to connect to that and download it. Or you can use that same broker and then pass through messages with blocks of your firmware, something like that. That's a different approach. Last but not least, the machine is sending out messages with information about the progress. We call that frequent logging, and there's a lot of that. Could be every second at the brewing stage. Fermenting is not so variable. You could say that changes are slight, so the logging, the sending out of the messages, the frequency of that is then way less than at the brewing process. But that is the mechanism that we use to get what the machine is doing. The machine is running its state machine, and we just need to read where it's at. So the machines are connecting to the MQTT broker. The applications are also connecting to the MQTT broker, and also the backend is connecting to it. So it's almost the central heart of this application, you could say, or solution. It works with channels, so you request access to a channel and then you can receive the messages. There's also something important that you need to be aware of that exists. If your machine drops the connection, you can, I mean, when the device connects to such a channel, it can set like a last resort information, and it's called the last will, I think. So that way that if it disconnects, at least some kind of last situation of progress can be read by or the backend or the application to have an idea where it's at or was at. And so frequent logging is going through there, so the messages it contains state information, progress, temperatures, not well written, and user actions. User actions are just an indicator like, hey, this user action needs to be served to the user, and that information about the user action and the steps that it contains, the videos and the photos and the description, and are all stored in the backend. So, but we need a signal from the device that a user action needs to be served. Then the backend has a lot of things, duties to do. Manage devices, registering devices, dropping devices, all kinds of stuff, users of course, a lot of things. But it also managed the brew sessions. So which recipe has it? Is it executing? What state is it in? Is it now in the base station or is it in the keg? That's important. It needs to serve information to the clients, to the apps, like, hey, this base station is ready to go, or your keg is ready to go, or show both of them, or maybe you need to clean your base station and your keg isn't fermenting, so then you have two entries in your activity list, you would say. Now, it also needs to intake a huge amount of frequent logging. That's a difficult aspect here. There's a lot of information. We need that information for analysis to troubleshoot if there's something going wrong, but also to see if something goes wrong maybe with the hardware, or why the user is stuck in something. So it can be software related, can be hardware related. So it's super important that we keep all that information, all these states, or not states, all these log messages. But it's just a whole lot of them. So that requires from the backend a certain discipline to be able to store that and serve that as well, especially for the web app that shows all a nice graph of the progress, how it's going. So it taps into this history of frequent logging to be able to show that. So it's a challenge for the backend side to provide that. And of course also the user actions, the videos and the photos and descriptions need to be stored and also be able to acquired by the applications to serve to the user. Then the Xamarin App. Just under the hood we use MVVM Cross and we use Akavash. Really nice. I like Akavash. So that's working pretty well. That requires reactive extensions because Akavash works with observables. So that's that. You need also an MQTT client and also make sure that it reconnects when connections drop and all that kind of managing. And there's also the Google Protobuf that we use there. I'll come to that later. On the right we have a nice screenshot from the Brew tab when you can start a new brew. So from the app you need to connect to the broker. So we use that MQTT client. Now you need to be wary of those connection drops and to reconnect automatically and all that stuff. And when your app goes in the background, stop monitoring, and when you come back, you can start up again. Those kinds of things. Also, your device can be offline. Simple edge case, but very frequent occurrence of that situation. And what I also talked about earlier, the slide before, it's the protobuf. So the protobuf is a way to structure and encrypt these messages that go to the broker and to and from the devices. So that's what it takes care of. It's kind of having a collection of classes and then you can just serialize it, something like that. Pretty easy to use. And that's good to have in a separate location because, well, we've got different sites that all need to communicate, so we all need the same protobuf spec to be able to read and communicate. So it's good to have this contract in one place. On this side we have the manage devices screen, and you see that my MIDI Brew is offline, so not very exciting there. All right, so most important of this application, the monitor side. So this is the screen. So on the right, you got your screenshot of what the monitor screen looks like. You got on top, you got the brewing, fermenting, and serving stages, you could say. Then you got all these states in between. Right now we're in fermenting, and fermenting in this recipe is doing a lot of clarification, secondary, primary. It's up and down, changing temperatures throughout the process. And this component is super cool, this circular progress bar. And it's indicating the target temperature as well, what is the current temperature. So it's a very complete view. It has on top when the next user action is there, so when you can expect to do something, to need to do something, so that you're aware. Normally it's not so important that you do it exactly at the moment that it should be done, or it serves you this user action, but at least you know, okay, so maybe it's better to stay at home at that point or something like that. And of course it also tells you when your beer is ready to drink, right? So user actions will be also shown in this screen, and you can see what the next user action will be. And it's a very, very complete, very kind of complex screen as well. There's a lot of things under the hood here. Also with this, when you lose connection, there's a whole lot of stuff going on here. Yeah, nice challenge, and I'm proud of how it looks like today. Then just on another note, it is a Xamarin app, but so it's a native app, and well, why is it a native app? Nowadays you definitely ask yourself, why do you make a native application? Well, it's just what the arguments were in the past, right? So the arguments normally are, okay, so I need either performance or I need a very specific UI. So if you need to tweak UI, it's a very difficult UI, then those were the arguments to do so. And when I joined this team, it was already set out, and that's just how it is. So, but those are the things that that people tend to use to decide. But of course, we are all aware of what Xamarin Forms with the hot reload and hot restart is nowadays, and iterations are therefore so much faster. And that's something that every app developer should think about if it is a viable thing to do, because you have a lot of time that you win there. So that's something that comes back every time, I would say, when you start working with a native application. The reasons here to choose native was what you have here. I tried to put a GIF in here. It goes a bit fast, but you see this wheel rotating and progressing towards where it is. So a lot of stuff going on there. So that progress wheel is definitely something difficult to do, or I find difficult, and very beautiful as well. And also another aspect here is that you get these messages from the broker, right? And you get that very often, and sometimes it even bursts you with messages. I mean, if there was a drop or something in connection, and then you connect it, just it bursts down. So you need to handle these very frequent screen updates. So there's not much margin for overhead on how do you say, reloading, redrawing your screen. So that's something that probably was on the weighing on the scales to decide for the native application. Now, just some final thoughts here and insights. Unit testing. This application works with observables. Akavash works with observables. That's really cool. Akavash provides you with functionalities like get and fetch. So get from the database, and also after that go and fetch it from the backend. And it will serve you first what's in the database instantly, and then when the backend comes back with your response, you will receive that as well. So you just tie into that observable and you'll receive 2 updates, which is really cool, good for responsiveness. But I find that very tricky to unit test, and a bit of a thing to do. It's a kind of extra work to do there. Doesn't make it easier to unit test. So there are definitely advantages to using observables, but I would also weigh the necessity of it, because I just find unit testing not so easy on observables. The screen redrawing is something that was actually a problem. We have a table view which redraws every update of the message, and we needed to put an observable in there that actually accumulates the change and just say, hey, I just sample 1 every second, and then with that we can update the screen, and all the others, it will just hold it and ignore it. So that's a very, very easy implementation with observables. So that's very well applied there, I would say. The frequent logging, of storing the frequent logging into the backend, that's also a challenge. I'm not so good with that. I'm more about relational databases and stuff, but that's something you cannot do here. Your tables would be enormous. So there's other techniques that you need to apply here. So, but it's not my area of expertise, so I cannot give you any hints there. Be very wary with when you're working with devices and connections. Of course, they can drop at all times. Make sure that you are possible to recuperate from drops and loss of connections. Make sure to test that a lot, and have maybe a battery of machines there to test against. And so yeah. Make that not a point of interest, but something you address heavily or a lot. Make sure that that works well. Also something very nice. So we had a very nice way of working. You have to understand that there are 4 disciplines in this team. We have the firmware, we have the backend, we have the web application, and we have the mobile application. So to bring that all together and prepare a release candidate is quite a challenge. What they do in that team is they prepare kind of end-to-end tests. So everybody provides the new release candidate of their part, and then a huge end-to-end test is done and executed. There's some automation there as well, but also manually testing needed. So it's kind of a bit different than from a normal Scrum procedure or Agile process. But it was definitely necessary here to have everything together, freeze that up, and make sure that you can do a steady testing of what you have. And of course, make sure that you work only on your release candidate and not push any new releases in there. There's just too many factors in there, too many different disciplines. So it was necessary to have that freeze up after every sprint, you could say. I'm very happy with the end results. It's beautiful. I find it beautiful, and it's a well-working app. And you have a nice screenshot here on the right. So I like this Lego photo. It's cool. I'm very proud of what has been achieved there. Also of what the hardware guys have achieved there. It's amazing. So, and that kind of rounds up my slide presentation. Got some more information here about our company, contact details and blah blah blah. And I want to thank you for being present at this presentation. I hope you enjoyed it. And well, have a nice Assemble stay, I would say. Goodbye.